So this is my SLAM robot. This is the RP LiDAR, which has the sender and the receiver. It detects objects around the robot, and if there is an object covering its path, it will not move. And this is my webcam. I'm using my own webcam for this project. And this is the Raspberry Pi, which powers the RP LiDAR and webcam, and also the motors. Now you can see there is 4 motors, and motors are connected to like encoder, which later calculates as a unit if motor moves 1 cycle. So example, if we want to move 1 meter, it will determine how many cycles we need to have to move 1 meter. And this is the battery, and this is the Arduino Mega, which has motors connecting it, and the MPU 6050 connecting to it. And that's all for the hardware part. So this is the final map that I have using the SLAM robot to map the 11th floor. I use RP LiDAR to detect edges and map it out and save the map. Okay, now we're gonna move on to our software part of the code. So in this project, we will have like a 3-step pipeline, which is 3 codes that we will be putting in the Raspberry Pi. But before we start all that, I'm git cloning this library to the Raspberry Pi, which is the Cascade library. It will detect. It's like a phase detector. So for our first code, train.py, it's actually a phase collector code. Like when we import it, it will load this Cascade phase detector, and then after that, it will ask us for the user ID. Which user do we want to put on? Either home, metal, or Timmy. Example, if I press Timmy, it will then open the camera, and then it will use the hard cascade detector to detect the face and keep the data as Timmy's ID. And we gotta repeat this step for like 1, 2, and 3. So next is the buildbrain.py code, which is a model training code which train the machine to learn the model of collecting images. How it works is that it will load all the pictures from the dataset and resize them to 200 by 200 pixels like this, and then to extract user IDs from the file name. So it trains an local binary pattern histograms facial recognition model, which learn unique face patterns and export final train brain as the trainer YML like this. And it will output model is trainer.yml. It's a file. It's like a model in the Raspberry Pi. So after the code run finish, it will show that the AI brain has saved successfully. Then for third step, the final step, is the vision and autonomous navigation, which is the face deliver.py. py code. So this code is quite long, but get to it. So basically, I'll just define the locations first. This is the location of like each post, like home, Matthew's office, Timmy's reception. It's like my naming. And this is like ID mapping. So like 1 is for home, 2 is for Matthew's office, 3 is for Timmy's reception. And so how it works is that it will open up a camera, and then if it detects example Matthew's face, it will then move to Matthew's post. Basically, that's it. It will then restart the camera again, and then see, it will wait for result, and then if the robot didn't go to the location, it will say navigation failed. But if the robot reached the location, it will say successfully failed. Or if it's like lag or something, it will then cancel the goal. Or if it's blocked, like the RP LiDAR is blocked, it will also cancel the goal and it will not move. It will just. But this code, I think I put in the. No, I put in the code that helps when there is like an object in the way. Example, if my leg's in the way, it will still turn the other way to find a way to go to that location. And after it goes to that location, it will then start the camera again and repeats the process again to go to another post. But if it's still in the same post and like it detects same face, it will say that it's in the same post. So this is the whole code. Now after phase 1 and 2, I'm going to test out the Python code. So I first bring up, then I run my navigation terminal. Now I will start running my Python code. As you can see, it's start running smoothly.